So let me get caption. All right, so this one is the IT service analyst. It's analyst level 1. So you do have incidents and service requests. There's, so some scripting. And then you can, and if you go to samanuelcareers.com/job, you can find it. This is at the Highland location. So even though it says right here, but it says preferred. So I think it's good for you, even though you don't have an associate degree, you should still apply because you're already, you have a bunch of certificates already, or you working on it. So you should list your certificate on your resume and pending. And I think now that we have a company to help you get your resume set up. And so you kind of have to go through this. You might not have this background. So I think once you have the gaming, it's like a process that you go through. It's good because you have to go through their screening background and stuff like that. But I think a lot of it is soft skills. And then, you have the A+, that's going to help here. And here, and a lot of these. So I think that you are qualified for, gaming license. So, you will have to get the gaming license to them. So they will have to go through the process with that.
What is the gaming license? What is this for?
It's for the reservation or the, they require that because it's a tribal commission funded. So basically it's background check and all of that. Like you can't have any crime. And if you committed any kind of crime that's theft related, they can reject you. So it's just focused on like fraudulent type of, so you can, you should take a look at this and kind of cater your resume to it. Nikki Cook, her office is like next door. You can always ask her to take a look at your resume.
I need help with that.
Yeah, and Nikki Cook, nikki.cook@nvc.edu. She
helps with resumes?
Yeah. So make an appointment to see her.
How do I just email her?
Yeah, you can email her.
Okay, so NIKKI.
KI.cook.
Cook.
Yeah, COOK@NBC. And and her office is right, and her desk is in the front. She does the career, and she told me that the career fair also have a bunch of stuff, so you might want to go. It's on May 24th. But reach out to her, ask her to help you with your LinkedIn profile and that.
Yeah, because I made it, but like I never went back on.
Yeah. So she can help you to put some content on there, and then she'll send you some resources. That way, and then if you might want me to take a look at your resume, I can also give you feedback. I've been working with some students and their resume is tremendously. I know Jose had come to me when he took the CIS200. His resume is tremendously better now than it was. So
because all of my stuff is like medical related or
so you want to keep some of it, and then you want it to add some of the new things that you've been learning and doing. But it's really, and then you can start with also doing like a letter and resume and things like that. So I can add you to the other Canvas shell that has all of that, all like the LinkedIn content. Do you have LinkedIn Learning? I thought I gave it to you guys, didn't I?
LinkedIn
Learning?
I don't remember.
Okay. I can check and make sure that you can use it. There's a bunch of tutorial that you can use to kind of like, and templates for resume that you can use on there. Okay. So since no one is here,
Is that not on there either?
I don't think so. Let me stop sharing. Yeah, he's,
Is that on there? Oh my god. He literally posted an announcement saying that we are in class.
yeah. And then also I just sent out a message. Okay, that's all right. So we'll just go ahead and get
Party of
started.
one.
Party of one, that's good.
Oh, there's Michael.
Yeah, he's getting dropped off by school. I didn't even get on Zoom or Office today. It's kind of- Hey, how are you doing? I always have an issue with Zoom on, let me try it on here. I have to record. How are you doing?
Doing okay. I kept forgetting to get to that,
Well, it's good because I had 800 questions for 90 minutes and I just fixed it. So I forgot to set the subset of the actual question pool.
Okay.
I didn't get to it either. We're not alone.
it's like, oh,
Yes.
You hurt your hands?
but you know, those arcade, punching thing?
Yeah.
So the one at the round one over here,
Uh-huh.
it's right on, like, on the corner or something.
Okay.
So I punched it and then I followed through and I hit the wall.
Oh,
Yeah, so my
Yeah.
fingers were feeling fun.
oh no. Hope you didn't like fracture it.
I think it's just a sprain.
I
Yeah.
thought that about my pinky when I was running to race my nephew and I fell, but it's been months and it still hurts. So I'm wondering if like, cause it's your pinky and it's so tiny, the bone here.
Yeah,
So like, I'm wondering if I did break it, but like, it's nothing crazy because it's like tiny, but I still feel the pain and that's why I'm like,
yeah.
It could be like just fracture.
yeah. I got so mad after that to myself. I'm like, why am I racing a freaking 12-year-old? Like, what possessed me to do this?
All right, so I'm just gonna switch to laptop. Because,
Well, they sent me the invitation to my mail for the banquet thing.
Yeah.
It wasn't like an email.
oh, good.
Yeah.
You confirm, I'm
Yeah.
assuming, okay. Yeah, they emailed me too. Sorry, I had planned for the desktop, but their applications are not functioning for the Zoom, so I'm not able to record on there. I did that for the Monday class and I forgot to tell them. All right. So we're gonna go over the notes and we're gonna go over the assignment. The assignment is a little longer today. One, I decided to size it down to one because the one chapter was like 80 pages or something like that. So it was too much and I didn't want to like. So I put it back to 13 and then 14, 15, and 16. We'll just hit it next time because the last two chapters are very short. It's compliance and risk management, but the 14 is a little longer for, and then it's gonna come back to eradication and all of that. So today we're gonna focus a little bit on forensic. And I think since both of you already took 27A, this a lot of it is review anyway. So for digital forensic, we understand that in order to perform this, we need to have a powerful computer, right? Multi-core CPU, a lot of RAM. GPU is helpful in the case where you need to do brute force. So that's always a plus. Sometimes that doesn't always come as its own adapter. So you want a graphic card to be able to use that for brute force in the case that you need. And then the tools that you would use, we know that we would use FTK, NCase. SAN has the SIFT, and then for the open source, you have the TSK, which is Slopkit. And you can also find additional open source type of application, which we're gonna use today. And then it's always good to get a right blocker. We're gonna look into one today. So for the questions, make sure you download the questions. We're gonna go over that, sorry. So for the first question, it asks you what type of tools do we need to perform computer forensic analysis? We should have a powerful system, right? Usually PC. You should have a good CPU, a large amount of RAM, so at least 16 gigabyte. Prefer 32 now, right? Because the more RAM you have, the faster that you can run some applications. As you know, that a lot of the application we use in this particular area of the field is going to be resource heavy. You need to have a good disk storage, okay? Graphic card, so your GPU. And then some of the software, we need some of the forensic suite, and you don't have to list all of them, but we know the FTK, NK slot kit, a right blocker. This is an actual device, or there is some software application, but it's not that great. So you would want to buy a device called the right blocker. This allows you to stop the system from updating the timestamp when you open up things, especially when you're copying drives. A drive deduplicator or drive duplicator, it is a device where you can take one drive and make the exact copy of it. Sometimes you can also use adapter or portable storage to be able to copy the actual drive. And we'll talk about copy and taking an image. What's the difference? Network attached storage, camera is always good. We want to have a dedicated camera instead of using your smartphone because of all the tags that's in the property of the image. Then also cables. So network cables, drive cables, USB cables, you name it. So a lot of the things that we see with like computer repair, we also need to also be able to use for forensic. Your drive adapters, there are different types of hard drives and also solid state drives. So we want to make sure that we have the adapter. Hi, we just got started. Yeah, labels, pen, notebook. I feel like, you know, a lot of it is still very traditional, but if you want to have a tablet to record your notes, or you can do that on your laptop. But I think in some cases you don't have access to electronics. You want to have pen, notebook, and then you want to have the chain of custody form. Every company uses different type of form. On the notes, I did put down the link for the form that you can download from NIST, which is a template that you can use. But you can create your own form if there's none, or you can use the industry template to make a form. So those are the things that we would need just to start doing forensic, right? Your physical system needs to be powerful. You need to have software on it. Make sure that you install it before you show up to the site. And then extra drives, extra cables, adapters, all of the things that we need to record and form. And so largely for forensic, we would see that it is resource heavy. So we want to be mindful of that. It takes a lot of time and resources. As some of you already took 27A, you've seen it. A lot of times, most of the times, right? My 27 class, I had them do autopsy on Monday night, and they love it, right? And the image that we use for autopsy was a very small image. So boom, it was done. It was just a drive. But when you analyze other system or the entire system, that can take hours or days. So we want to make sure that we understand that forensic is not something that you can do on the fly. Yeah, so today we are gonna do something that's short, but there is so much more that you can do with the tool we're gonna use today, so. I originally wanted to do the data leakage case, but when I went to download the image, like when I test the lab and re-download the image, they had all their links were disconnected, so they had moved the server or they disconnect the link, so there's no, so I had to do a quick change where I, so we'll talk about volatility and how that's important. Okay, so where can I find all of this information? Sorry, I uploaded the wrong notes at the beginning, but it's corrected now. So you can find all of that on page 1, right? You can copy and paste it. And so when you go to the forensic site, make sure that you do have drive storage. You can also make sure that your drives have been wiped, because in some cases you cannot mix data together, especially when you deal with law enforcement and litigation. You have to make sure that you have dedicated encrypted drives. So just keep that in mind. Okay, so all the equipment stuff, all the things that we need is on page 1. And then the example of the form, I put the link there for you. Now, when you saw NCase and FTK, they do have some free version. However, you're gonna find that the free version doesn't have all the feature. So the commercial tools, that's very popular, and they do certify. NCase have certifications, different level. One of the area that you can get certified in forensic is GIAC. That's another set of certification. They're kind of big like CompTIA, but it's really focused on forensic ethical hacking, kind of like EC Console. Okay. EC Console also have forensic specialist certification, but they're very pricey. Yeah. So I really feel like if this is an area that you want to get into, I think GIAC is probably good enough. And I do have, I think I gotta check my license, but I do have practice tests for the EC Console one. Okay, for the mobile device, which is question 2, a lot of the mobile devices use SIM and also flash memory or your micro SD. So make sure that you have to have a SIM reader and a micro SD reader. That's where all the data is. And then the internal is, we can analyze RAM, so we can capture the image of the Android or the iOS system, and then we can analyze it using some tools, but you need to pull the data. And the SIM is very important, as you know, that it's used for connectivity. So if you're trying to find out if that person was at a certain location, a geolocation, SIM will be able to give you that. Okay. So the eSIM, you treat it like a drive storage, right? Like a flash drive. So you should be able to analyze it as long as you make it into an image. Okay, so for the second question, it asks you what type of tools are needed to perform mobile system forensic analysis. So you would need a SIM card reader. I like to have those, the SD adapter, the large one, because some of my laptop actually has a slot for it. So it's useful to have that, but if you can also buy the USB base one for the micro SD, if you don't have a slot for the SD. And then the micro SD usually goes into the adapter, and then adapter you can slide it into your computer, or if the adapter is USB based, you just attach it. You need to have extra cables, very similar to the other one. Now, on the mobile type of system, you need lightning cable, you need USB-C cable, you need the mini micro USB, you name it, right? A lot of it is for data transfer, and then sometimes for power base. So we want to be able to keep it running. And then you would need software tools. Now, if you're using NCase or FTK or some of the kits, they do come with a mobile option or feature. But if you're using specific tools, you just gotta make sure that it is for mobile devices. Okay. So they recommend that you use the toolkits like FTK, NKs, block kit, what else? Like the, you know, so you would see a lot of the comments one there. Now, when you start doing an analysis, the first thing that we want to do is we want to kind of document the scene, take pictures before you start touching anything. And then after that, you would need to make an image of the drive or the system. So if it is in an entire computer, if they confiscate the computer and you're supposed to analyze it, if the system is running, you can do live analysis. If the system is not running, that's what's called a dead analysis. That means that we capture the image of the system, which contains all the files, all the applications, all the things that's on there, and be able to put it on our drive and analyze the image, not the system itself, right? And then you also want to make a copy. So I normally start with 2 copies, right, of the image. So I make an image and then I make a copy of it, just in case, right? If I mess up on the first image, I have a second one to go on. Otherwise, you have to go back to that system and then recreate the image again, and it's a waste of time. So when you copy the image, it's a fast copy anyway. Well, it depends. Some system has very large drive. So my students asked the other day, like, hey, can I use autopsy on a 4 terabyte drive? I said, sure, but it's gonna take a long time, right? It's gonna take hours and hours. So even if you run it on a gaming or powerful system. So the purpose of imaging tool is to make a forensic image. And you often see them as a .dd file, or if you use commercial tool, it will be like E01 or E02. So the extension of the file is specific to the application that you use for imaging utility. Now in Linux, DD is free. So you can use like, Ubuntu or whatever and install DD, or if you have Kali, I think it's there. So you can use it to create your disk image. And then we want to also copy the section of the disk, right? And then the logical volume. So the disk is divided into partitions, section of the disk. And then sometimes we can also create logical volume. So it might be multiple partitions for one volume, right? Or 1-to-1. It all depends on how that was formatted and created. Because a lot of the times we will work directly with the file system and then also the allocated and unallocated space itself. So we want to make sure that we have that. Okay. Any question? We got 25 to go, right? Or about 22 more. So it is a little longer because this chapter I originally was like, oh, I'll just knock out 2 chapters this week, but forensic is always like, you have 1 chapter where it should be a course, right? So 27A is the course. Okay, so let's talk about drives.
That's why the lab is good.
Yeah, hopefully it scans quickly. The update and the upgrade part is going to be long. So if you get through that part, everything else is quick. So here I listed some of the tools. This is SANS, right? You can download Autopsy. I think some of you have seen this before. FTK, when you install FTK, it requires like a database because it likes to pull the data and then put it there. So you have to enable some of the resources and the packages that's needed. So make sure that you see the documentation. They do have a quick guide and they have an extended guide. So it's not something that you can do in a few minutes and then start doing forensic. So I want to let you know that you need to make sure that you prepare software before you go. All right, imaging. So here it talks about slack space. So slack space is where the space that's left when the file is written. It's also where after the file is deleted. So when you put it in the trash can and you empty your trash can, that slack space can tell us a lot about delete files, hibernation files, files that were written. So fragments of the files might be left, and some software is really good at recovering the files from its fragments. because a lot of times we identify files from the file header, which contains the file property information, like, what type of file it is, the size of the file. So, and then anytime that you deal with malware, sometimes that you also see it in RAM and also see it in storage, hidden files can also be found in Slack space. So we cannot disregard areas that are not allocated. And then unallocated space is crucial. This is where you would see that this is where that things are not divided on the drive. There's still space left on the drive. People hide things here. There are ways that you can hide things here, so we want to make sure we have that. So to answer that question, right, for number 4, we state that it asks you, why should Slack space be an unallocated space be examined for forensic in the forensic image? So you want to capture all of that, right? All the drive space, which takes a long time because it might contain hidden files, deleted files, fragment files, and then unallocated space also might be hidden files, drive logs, very important, because somebody can delete a drive very quickly, right? And we can actually identify that looking at unallocated space, because if I commit a crime and I store something on the drive, right, on my computer, like drive E or drive F or whatever, I can right click it and I can delete it. So that drive space, if I have privilege, that is, would be given back to the unallocated, but you can find that in the log files, right? And or if they rename the drive, if they, so the logs are important. So in the next section after that, here, right, it talks about, so the utility, you start with the imaging utility to create the image, then you get into the analysis utility. So the features for these are, it's going to tell you when things are changes in the system. It also gives you validation tool, which is all hash based, right? MD5, SHA-1, and so on. Then it also does file system analysis. This is very important. When you deal with Windows, this is crucial, and this window registry. And then for file carving, it's good at recovering files in the case where they delete the files. So we'll talk about file carving. And then also looking at log files. So these are some of the main criteria for analysis utility. So to describe the purpose of forensic analysis utility, it is used to discover occurrences in the system, what had happened or what occurred in that system, such as system changes, known good files, deleted files, file system metadata. A lot of the forensic tool, all the forensic tool actually analyze your file system through its metadata. And it's able to perform file carving, parse log files, and then do Windows registry analysis. So I should capitalize the Windows, right? Registry really tells you what happened to the hardware and the software. It's a way that Windows operating system keep track of what has been changed in hardware and software. So when you install an application, registry updates its key. When you install a drive, right, because you have to install driver, or when you install a hardware device, registry also gets updated, because the OS is a way that we manage resources in the system. So registry is the database for all those resources in the system. And then it also contains user type of information. So it's always good to do registry analysis. So when you work directly with Windows system, registry analysis is essential. And so when you look for forensic analysis utility or the toolkit, you want to focus on these main areas, right? You go through the checklist. Does it have this feature, this feature, this feature, this feature? And then also how easy it is to use, you have to link it to your data source, which is your image file. And then it's gonna be able to pull. Like, I really like Autopsy for the fact that it's free and it is very easy to use. It's comparable to some of the commercial tools. But with the commercial tools, the cool part is it does a lot of like the analysis report for you. So it graphs everything out for you. It would also give you additional features. That's what you pay for basically. Okay. Any question? All right. Okay, so for file carving, as we talked about, this is a way that we can look at files or we can recover some files that are deleted. So file carving tools, what it does is it does block to block analysis. As you know, when you write files, they're not just together in one section, right? It kind of spread apart. So what the system does is when you run the analysis tool, it's going to examine each block. So I can have a file called file1.txt, and that file is in several blocks, right? Depending on the size of the file, right? And so when you're looking at like a hard disk drive and HDD, it can be in different platters. It can be in different section of the drive. So what it does is it's gonna look at, depending on the file system like NTFS, right? It's gonna look at where the address of that file location, and it's gonna examine each of the address that's associated with that file. And so based on that, what you would see is that first, it's gonna look at the header and the footer of the file when it carves, and that will give it kind of general information about what kind of file it is. So when we're looking at a JPEG, right, it's gonna go to a certain section to look for the header, and then a certain section or the certain block to look for the footer, because they're not always together. They're never together actually, because it's dynamically writing. And so when it carved, then it's gonna look at the content of the file by going through and looking at, whether it's text, if it's an image, right? It's gonna look at like the type of image that's used. When you carve, you're gonna carve raw file. So after that, if you use a good software, it's gonna convert it to what you see as compressed or prepared file, like for JPEG or MP3, etc. Raw files is not in that format. So a lot of the times when you carve, the raw files is as a whole is large, and then it's gonna convert it for you with some of the software. So to answer the next question, the purpose of file carving in forensic and the 3 common carving methods, right, are, so your file carving tools look at the data block by block, and it's gonna look at the information like headers, footers, indicators of the file structure. That's gonna give it the general interpretation of what the file type would be, like a text file, an image file, a WAV file, etc. And then when the files are found, right, it would then try to recover based on what's left of the content or what's there. Sometimes you would get partial files, right? Because when a user delete a file, it doesn't really go away until that section of the drive is overwritten. So majority of the time you will find that in Slack, and pulling that from the Slack is going to carve it. So if I have things that, store permanently, that would be the case. But what if it's an application file? Then you would then have to carve from memory, right? RAM. So you would then use volatility or some kind of framework to pull from RAM. So when you have a system that's running and they confiscate a system and you're doing analysis on that system, likely that you will need to start with the drive, right? Doing the live analysis, and then you will carve the RAM. Do not turn that system off when you do live analysis, because when you do, it resets everything, right? So you have to keep it running, and then you want to be able to carve it while it's running. I was telling my Monday night student, I think I probably told some of you. One of my friends ran, he was an administrator for City of Loma Linda, and they ran out server racks to local companies for hosting. And then he discovered through analyzing the traffic that one of the client was serving pornography websites. And he was selling subscription to the users on that website. So he reported to law enforcement. They came and it was out of this house in Loma Linda, right? He was like a son of this older lady living there. So they confiscated like 10, 12 systems. So he was running, like he had these images stored on these systems and he was serving it. So he was using the rack space, right, of my friend's network to be able to kind of get people from all around the world. So when they confiscated that, they didn't want to turn off anything, right? So the forensic analysis, when they showed up, they had to capture everything and then they have to run live analysis there because you want to kind of get the evidence while it's running, like who's on that server system, who's using it, who are the users, and then they also went to the data center and then pull the information live from the server. So incident response is that, right? So when you deal with incident response job, a lot of it has to do with forensic and auditing. You're finding out what just happened and what's happening now. And that's what makes this job really high in demand because every situation is a little different. You might get a forensic case that's similar and then you using the tools and it works, and then you go to another incident, it's a little different. So like I said before, your tool belt, your versatility and your knowledge is gonna go a long way in this field. Okay. So for the 3 common tools, you can pull that from the notes, the header and footer based carving. This focus on, finding headers for the files. The content-based carving, this is the information about the content of the file, like looking at characters count and text recognition for text files. So it's really good. A lot of the software is really good at doing text content, Word document, PDF, because, a lot of that is generally used in many businesses. So they build it to really recognize text quickly. So for any type of text, document is fast compared to when you do videos and sound is very long. Okay, because it has to pull it raw form and then it has to convert it. So that process takes a little bit of time, depending on the size of the file. I do like this area. Sometimes, depending on the contract, sometimes I don't like it. Just the fact that like, if you go to historical stuff, sometimes you can, if they have litigation and they pull, I had worked for a company that was investigated by the FBI. They pulled 2,000 hard drives, 2,000 systems. And when they have litigation hold, and I forgot to talk to you guys about that. So in the litigation hold, like you cannot make any modification to the drive itself. So you can't store additional file to that exact drive when they hold the drive. It's there, right? But you cannot do anything to it. So you have to either encrypt it, lock it somehow. And in that situation, you would see that it's, 2,000 drives. That's a long, long process, right? Okay, so for the third part, file-based carving for the structure. So file structure-based carving, this is used to really build up the structure of the file. So just, on Monday, they asked the question, how fast or how easy it is to build a file? Well, it depends, right? In this industry, you hear that a lot. It depends. How big is your file? What type of file? The state of the file, was deleted, has it been wiped? There's a lot of things. But in general, when you go to e-discovery or a company that does file recovery for you, in the case that people delete files or files got destroyed, they normally charge by the size. So when you're looking at like megs, right? It can go from a few $100s to several $1,000s. It depends on how critical, sensitive, important, so yeah, they charge it based on your size and level of difficulty. So when you do all of this, you have to manage your chain of custody. So chain of custody allows you to document, right, where and who and what was done for the forensic. Okay, so if you confiscate the computer, right, you've got to check it into evidence center. If you work for law enforcement, they have an area where that's where they put all the evidence, right? So the technician there, they sign it and you sign it. So the incident responder and then the law enforcement facility. And then as you check it in and out or who access it, everything gets put down on paper or on the form, right? Who accessed it when, what was done with it, bust you, right? So we want to make sure we manage all of that. So, but this can be automated and logged, right? Sometimes some suite actually have all the feature that you need for this. So this is to make sure that your data has integrity and your drive has integrity. So you got to make sure that you validate it when you review. So when you put together your report, you have to put your hash, right? What the beginning value, and then when you validate it, it has to match. Okay, and you have to put that on the document. Otherwise, it will not work. And because the attorney, they would argue otherwise, right? Oh, your data doesn't have integrity, so it gets thrown out of court. They can't use it as evidence. Then you have to start all over again. All right. So there's a huge need for this. I looked online all the time from national security level into even, local level. If you like this area, sheriff department is where you would start interning. It's hard to get internship in this area because it's far and few. But once you're in with law enforcement, there's a high need in all area. You talk to my colleague at Ben Clark Center for Crime Analysis, they'll tell you the same. You can be a technician and you can make like more than some people make as a manager in the hundreds, like 100 and something thousand. So here it talks about legal hold. We touch on that hash validation. There are hash utilities that you can use. Some are free, some are not, right? Just to validate your hash. Some comes with the suite like Encase. And then I also put down, how can you validate, right? How do you know? There's checksum that you can use. But you can also look at file repository from OWASP and NIST for software for application file. So that's useful. Okay, so the links are there. Now for the endpoint, that's your desktop, your laptop, every other things, all your smart devices. They also fall under mobile too. But for system, like servers, you need this. Okay. So you need to look at OS, memory dump, and process analysis. So for A, when is legal hold conducted? Right, we touch a little bit on that. So that is conducted when there is a legal case, and that could go on for years or months. And the tool that you often see with legal hold is e-discovery. I met the CEO for this when I taught at a private school. They asked to come and present to my students because they were recruiting. And yeah, so it's a very popular tool that you can use. And then you often see a lot of entity use e-discovery. And you can subscribe to their newsletter and stuff. You can look at like the career base on that. And we talked about how we can validate hash for integrity. This allows you to ensure that your copy we say copy, but it's really an image of that system match between the source or the device and your copy. Integrity validation allows you to verify match hash value of your image, your file, your binary files. So when you deal with applications, it's binary files. This is used to detect change. This should be half when hash values. So if change were made, the hash values will be different. I think at the beginning of this class, we talked a lot on that, right? We talked about hash for integrity. And in Kali, there's also tool that you can add. There's also suite that you can add that has, hash validation mechanism. But almost all the forensic toolkit that you see now have this. Any questions? So when you perform your endpoint forensic, you need to take a look at your OS, the data that's stored on your OS, your memory processes, encryption and decryption keys, your memory dump, encrypted files, crash dumps, and hibernation. Crash dumps is for applications purposes, right? And then your hibernation files. You guys know what hibernation files is? So when the system goes to hibernation state, it saves the state of the machine. And also these hibernation files used for reverting the system back into its previous state. So like I have a bunch of browser open, right? You ever walk away from your computer and it goes to sleep, right? So it stored the state of that machine at the time that you walk away, right? Before it goes to sleep to the hibernation files. So it's very useful in the case that, let's say that the system goes into hibernation and then there's an attacker, he later accesses that system and he uses it. We can go and pull the hibernation file, before the fact that he delete some of the files or things and install things, right? So it saved different stages of the system, and that's why it's so important. I'm gonna attempt to log into. I think the Zoom on here is not updated. While you guys are reporting that. Zoom text. So frustrating with. Any questions? No questions?
Professor,
Hmm?
how did your friend and Loma Linda come across that data again? It was scanned?
He's the network administrator for the city at the time. Joe, he's long gone now, but at the time. And he noticed that all of a sudden, like all this really weird traffic coming in. he run network protocol analyzer all the time, right? And he noticed that like it was coming in from Europe and a lot of like public IP that's his, and he got notification on the appliances that like, yeah, there's a lot of traffic coming in from all different part of the world and and then he also noticed that there was some server that was pulling from it. So he started digging into it. And then because when you reserve like data center host space, you have to kind of tie your domain with it. So he was tracking down like the domain. So he registered it as a common regular domain and he had linked it to another domain that he had added somewhere else to kind of host these things. So he was just like footprinting it and then that's how he found out. And like right away they called the police. And then when they started tracking it, right, they go through and they look at his registration, who is it, and you can see that publicly. Who is this person? They identified like how he paid for it and where his address was. It was I don't think it was actually in Loma Linda. It was like San Bernardino. It was out of like an older house. It's his mom that lived there. He was like, he had all of these systems in the garage. So they pulled all of the systems. So
technically your friend did what kind of say passive reconnaissance, but I'll lean more toward active.
yeah.
But he didn't go into the server rack.
Oh, he analyzed because everything passes through the data center. So he just did he runs things like Wireshark and then he looked at the packets. And then so that's how he found it actually. And then when the police came, they actually pulled the server systems from the guy's house.
Great.
Okay. So let's talk about live memory analysis. We're gonna do some of that today, but not live. We're gonna do data analysis on memory. But you can try to do it on a system at home once you know how to use it. So why do we perform live memory analysis? To gather evidence. I kind of touched a little bit on this earlier. When you do live analysis, it's something that when you turn it off, it would change its state, right? It has to be captured live right then and there. For example, applications that are running, things that are being transferred, possible transactions, web-based things, encryptions, very important because when you turn off that system, it stops the key and then it won't be able to decrypt or encrypt. So anytime that you deal with the state of the system at that moment, you have to do live memory analysis. Also, very good for when you do memory analysis in general, you can pull encryption keys, password, which is what we're going to see today. Network traffic, very important for live analysis. And you can do it directly from the server or the system RAM. Sometimes it goes through switches and routers and they all have RAM. You can actually capture your, Cisco switch router, any kind of appliances, security appliances. You can take an image of it. They all have OSs. Most of them are embedded Linux to be able to get some data out of it, right? Network analysis for forensic is a humongous job when you think about like how big of a segment that would be, how many appliances that you're dealing with, all the connected system, right? So that can be tremendous amount of work. Or if you're dealing with one system, that's different, right? One server, one endpoint. So password and encryption keys, you can pull that from the crash dumps, as they are application oriented. Okay. The majority of the time, right? People log into things through an application. People encrypt things through an applications or an interface somehow, like web. So RAM really pertains, a lot of it has to do with like OS and applications. But OS also drives, right? Okay, I put this question on here because sometime like when I do workshops, people always ask me this questions because they're always so curious about when we do analysis or forensic on mobile devices, which is very common now, very, very common. So in the case where if the police confiscate like an iPhone, an Android, a tablet, a laptop, right? Now on an iPhone, they can quickly lock the phone, which what that does is you have to unlock it to access it. And you see this on CSI a lot, right? You watch the show and they always show like the computer forensic technician trying to access the phone without knowing the passwords or the PIN or the biometrics, right? A lot of times, 99% of the time, we brute force into the phone or the device. There's no other way. And that takes time and resources, right? So you would use brute force applications. A lot of the forensic toolkit has this capability. Now on the PIN, brute force is easy because it's 0 through 9, right? Sometimes people would be clever with the swipe and then, or there's a way that they can actually access, like, you guys ever seen those applications that store all your passwords, right? It's stored somewhere. Sometime that's on the cloud and they might be able to get it from the vendor or the people who manage or provide service provider for the cloud. But the easiest is to do brute force. Okay. So when it's locked or encrypted device, you're going to brute force. The common technique for this is you are going to use your mobile device applications to be able to retrieve the data. And I would recommend doing RAM analysis on it because every system has some form of RAM. And through the RAM analysis, you get a lot of things. Okay. And then you got to pull the SIM, you got to pull the micro SD if it has micro SD. Most of the devices now they sell them with internal storage. So you will have to do internal storage analysis. So plug it into your computer, take an image of it, then copy the image and then do the analysis on the image. Okay, and then sometime if it's still on, you want to capture it as it is on. All right, any questions? So I'll talk a little bit about Packer shortly.
Give an example of specialized encryption.
Specialized encryption. Now I think everybody uses like your standard encryption. I think back in the day you would have like BlackBerry has their own encryption. Some like smart devices has its own encryption, but I think now everybody just agree that we're using SHA, we're using like, certain, but PKI, stuff like that would be. But, like sometimes could be application oriented, but even with application oriented, they stick with the standard. But back, like, I want to say legacy wise, when you work with legacy system, you would see like specialized encryption because they are proprietary to the manufacturer. I haven't seen a lot of like security applications for like email and things like that using any kind of unique algorithm because most of the encryption algorithm, it doesn't make sense for the developer to write their own algorithm or go out there and pull something that's already been, tested and standardized and then incorporate that to the application. But that reduces it increases the vulnerability because it's just more common. However, there's only like a handful of encryption algorithm that's like truly unbreakable,
It's pretty much doing research into the device you're linking into.
Yeah, MIT might have. I'm pretty sure they have stuff that is proprietary to them, to their research, and then they might turn around and they will sell it to a security company. So you might have specific things like that for security applications. Like they would sell products for like encrypting drives, encrypting email with a certain algorithm. But a lot of the algorithm that's in the field now is built on existing algorithm. We in technical, we don't know, you rarely see things that are built from scratch anymore. Because why? When the libraries and all the source codes that's already there. So it makes more sense to build on top of it, like modify it and then make it your own. But you have to get like permissions to do that too, so. So some of it today, we're gonna also look at malware, right? So here it talks a little bit about forensic. For Drive, we are gonna use Volatility 3 today, one of my favorite tools. But you have to kind of know how to use it with Python, because as a package, without Python in the back, it's a little bit clunky. So, all right, I think we touched on the mobile ones. So for the 4 primary modes, make sure we understand this, right? You can physically access it, you can manually access it, and then you will access its file system. So this kind of break it down to like SIM card memory and backups. And then for the logical, you would do, your analysis tool. And then you would also use live, right? Once you get it unlocked. And then you also analyze its file system. So most of the devices now fall into 2 categories: Android, which is Linux based, and then iOS. Here's password cracking, a little bit of this. I think the author for this book didn't really go in extent. I think there's some questions. So some of the things I highlighted will show up on certifications. So here are the packers information, right? So coming back here. So packers in malware are, this could be a form of encryption, but a lot of the time it is a package that they use so that way it would protect reverse engineering or security application from detecting it as a malicious tool. Okay, so it's built in with the code or on top of the code. And so to really see it, you have to decode using your IDE, or you can unpack it. Okay, and sometimes they would use like base64 encoding. As you know, that we would have like different schematic on how we encode, like UTF-8, which is very popular, right? So you have different encoding. So encoding, what that does, it converts possibly text or symbols into something else. So when those symbols are not recognized by a certain application, it goes undetected. That's basically it. Oh, sorry. Let me move this down so we can see the rest. You can find packers on the notes as well. And then after that, it goes into logs. I'm sure we beat you to death with logs since day one, but that's the core in this field, right? So logs can tell you every occurrences in the system. So log files is essential. So we want to be able to get information as far as system state, the type of actions or activities that happen on the system. If there was some form of errors or problems, that could be generated from application itself. And there would be lots and lots, like user logs, information, the files that they access, permissions, privileges. There's so many things that we can do with logs. And in order to view your logs, you would use Log Viewer. Now, Forensic Toolkit has Log Viewer. Sometimes you can use a separate application for that. You can also use text editor to be able to read some logs, because a lot of the logs are text-based. Now in Linux, you would see the .log file, right? And so you can use like your nano tool to be able to access those files, or if your embedded Linux system has log viewer, you can access that. Now we want to do this in the image itself, because when you open the logs, it changes the timestamp for that log. So we want to use forensic tool to read the log. So that way it doesn't change the state of the log. Because you have to validate that too for legal purposes. And then for the networks, also based on last week, right? Protocol analyzer is essential, like Wireshark and other protocol analyzer. The tools that you see in Linux is your TCP dump. And TCP dump is very popular, been around for many years. So you will find it in Kali. You can also install it if you don't have it for like Debian base or other versions like Fedora. I think they like to use TCP dump on competitions like Cyber Patriot, National Cyber Leagues. So a lot of the cyber challenges, I wanted to maybe for when I teach 27A in the fall, they just released the new cyber challenges image on NIST. And I was trying to pull it today to take a look at it, but so it's blue team based, so you do like network defense. So if you are interested, I'm gonna like switch gear real quick. You can search for NIST data set forensic, and you will find, and some of you've seen this before, you would find the CFREDS portal. On here, there are many images that are already been created. So I tried to pull the data leak one from here earlier, and it didn't let me, but you can find a bunch of them on here. So the Cyber Defense Challenge, they just released that. So if you wanted to play with it, you can download it, and then you can use like Autopsy, FTK, or any of the suite, or even soft. You can see what's there. So when you deal with network forensic, Wireshark is really good with it. You can pull in the PCAP from Wireshark, and then you can look at the capture, or you need to capture the traffic and then look at the traffic, and then look at your packets and then follow the packets. Okay. And beyond the network, we have the cloud, which is just remote servers elsewhere. It is harder, right? So because now it's someone else's property. So when you deal with cloud forensic, first, you need to make sure you evaluate your contract, and you can find all of these bullets on your notes. Second, you need to look at your legal requirements with the vendor. Sometimes they don't release anything unless you have a court subpoena. So that will take months as well. Okay, but evaluate your contract, making sure that you go through the legal steps to be able to obtain the requirements for forensic on the cloud. And then the area of your investigation will be focused on the type of data that you want to pull. So that is going to allow you to think about like the methods that you're going to use and how you will be able to control that. And then you work with the vendor like AWS or Azure to be able to identify the course of action. Because you don't really have, it's on their system, so they have the right to review certain things. So we want to make sure that we have proper permission to access things. You know, lots of companies put stuff on the cloud now. So investigation on the cloud takes more time as far as, you know, getting access to what's allowed. So if you have a hybrid, or if you have a private cloud, you have public cloud, it's really depending on your contract, right? What you can pull. And then they also allow you certain time limit to access it. Any question? So I'm pretty sure that when you take this certification, they will ask you about cloud and virtual machines. I think I put the next questions for the virtual machines, so this kind of fall into the similar category. So for 17, when conducting forensic investigation on virtual machine and containers, so those are Dockers, right? And though you'll both differentiate between containers and virtual machines. I'm sure you're very familiar with the VMs. You can have VMs on the cloud. You can also have containers on the cloud. So basically you're just taking a storage and you can make it into a certain environment for container. The hard part about the container is it's used temporarily. So you don't often see Dockers and things being used permanently compared to a virtual machine. So virtual machine, they can be instances on the cloud where they can be used permanently as servers or, systems. Whereas containers, they often are used for testing purposes, for a period of time, and then they get removed. So in that case, containers are a little bit harder to be able to do forensic analysis on, because if they're no longer there, you have to go dig around and find it. But for the virtual machines, it is a little bit easier. Now, the data that you're going to pull from the virtual machines are going to be harder, because a lot of the time, sometimes the virtual machines are a little bit isolated, and to obtain the data from it, you have to transfer it to other media. So you have to take an image of that and then see how you can pull the content. So some of those are some of the challenges that you would see. So the restrictions and the limitation that you see is what can be copied from the virtual environment. And sometimes you can't copy everything, right? A lot of times we treat it like a regular system, but the data, we expect it to be less than a regular system. The internal lots for the file system, for the artifacts, because I talked about the containers, how it is temporary. It is software defined, so it is not something that you can have permanently and easy to access. Okay. So we have to really distinguish the difference between containerization and virtualization. They are different. Okay, a lot of people kind of lump them up into one area, but the way you treat it as analysis is different. And there are tools specifically for container, and then there are tools for virtualization. So let's go a little bit in depth with your files, right? So evidence is considered artifacts. This is how we call it. And so for your deleted files, right, where can you find specific files? So we talked about slack space. The system would usually manage your files like a table type. It indexes all the file based on the file name or its header, tying to the addresses where that file is located, whether you're using SSD, HDD, or in the case of different file system, doesn't matter. There is a way that it indexes the files, and then there are change logs. Okay. So anytime that the file state is changed, it updates the logs. If you want specific file that's pertained to an application, so for example, I'm looking at like Wireshark file, right? Which is your PCAP, your capture. It is application specific. Only that particular type of application can open it up. I think PCAP, you can open it up in other application that reads capture as well. However, you would look at the application logs for that. Okay, because it is application oriented. Almost there, little more to go. So for forensic, when we start, we can, before you plug your system in, right, you would use a write blocker. So how is forensic image created? What must be done to validate the system image for forensic investigation? You would use write blocker, which is a device. You can also use the software tool, but that's not very common. You would use the application for imaging, right? Some toolkit has that. And when you do that, you plug the write blocker to the system storage. And what that does, it prohibit the change of timestamp when you're accessing the storage itself. Okay, so it's gonna take bit by bit, it's gonna write from one side to the other side as far as image. And we would use that image before we use it, we would look at the hash. And we want to validate the hash of the storage itself that we captured from compared to the hash of the copy storage on the image. Is it matching? Right, that's how you validate. So hashing and validation is needed at the beginning, right? When you get the image before you start looking at the artifacts. Any questions? Now, the difference between copying and imaging is that when you copy, the copy command does, so if I'm copying a drive to another location, right? Like I copy drive E onto my external hard drive, which is drive Z, for example. It doesn't pull the slack and the unallocated space from the disk. But when you do an image, it takes the entire state of your source drive and then put it onto your destination drive. So copy command only take the allocated space of the drive. That is a lot faster than imaging. However, it doesn't give you everything that you need. In the case if you need to look at specific, right, like your specialized file, like deleted, hidden, hibernation. Any question? Okay. So let me move this one down. Okay, so we talk about how it does block to block, right, bit to bit. And when you're using a utility for imaging like DD, the default is 512 bytes per block. Okay. Now you can modify the application to write larger block size because larger block size is gonna give you faster speed and it's gonna give you less time. So in the case that when you're dealing with like 4 terabyte drive, right, I would change my block size to a larger size. You can go all the way up to the 1,000. And that is gonna make it faster to create or write that image. Because if we rely on 512 bytes, that might take a long time, right? You can compute it. Take 2 terabyte, you divide it by 512 bytes, and you would see. Okay. Even on the fast system. So when we change the block size, we actually would be, now, not always that you can change the block size. Some application won't let you change the block size, right? It is defaulted to a certain block size. I think FTK, the maximum that it'll go is like 1500, which is pretty big. In the case where we have mass storage, like network attached storage is huge, right? But on other application, you would see that it's limited to a certain size, right? It'll tell you, it will let you go up to here. There's certain option that you can select. So I want you to kind of see how the blocker works, right? Whenever you use any device, any tools, anything for forensic, you always want to validate that device. And then when we use one tool, not enough, right? We want to use multiple tools to perform the same, to produce the same result of analysis. I'm sure I'm harping about this to the CIS41A students that's in the room many, many times. I was like, when you scan once, that's not enough. You're gonna scan 2-3 times with 2-3 other tools. And if you have the same consistent result, that's what you're gonna take to court. You would also write that in your report that you produce the same result by after 3 analysis using 3 tools. And that's just a scientific way to show that you have consistency in your outcome, right? But scientifically, we would do it hundreds and thousands of times, which we don't have time for. So 2-3 tools. Okay. So what I did was I give you this link. You are going to access it. But you also need to find a write blocker that you want to use. Like, just pretend that you are doing this, right, for money. And you would search. So let's open up a tab. And then you can just search for write blocker. Okay, let's go with this one, Tableau. I was just at the conference, but they make all kinds of things. All right, so this is right from the Amazon. So we just need to record the model, because they have different model. So we know that the type of tool that we're gonna use is this, right? I'll just paste it there so I don't forget. Then you go to the NIST website and you're gonna look this up. Okay, they do have a lot of the updated things. So first thing I see, there's 2, 3. So I'm gonna go with the USB write blocker, the second option here, right? That's the one I selected. So I'm gonna open up the PDF. And then it's not very long. So basically what they did was they took the write blocker and they put it through tests. And this test is validate that it is not changing the drive itself, right? So you want to look at the result for the test. So here's the test information. They tested it on the Windows Pro, right? And then they put down, here's the serial number for it. The disk that they use. See how this is very similar to forensic tests. Is when you do tests like this, you got to record all of the things. The interface USB, the drive that they tested is SATA. So it passed, right? No sector on the drive were modified during the test. And that's what you want. You want a pass device. You don't want just any kind of device, okay? So the model that you pick for write blocker should pass, and it should not modify the drive when it reads. Because it's gonna read the drive and it's gonna write to the destination drive block by block, right? So we want to make sure, or bit by bit, we want to make sure that it doesn't change the source drive, our evidence container. Okay. And then additional results here. So there's no errors, that's good.
For the result, is it okay for you to unmodify sector?
Yeah, that's fine. So what I'm showing you is before you decide, right, to go with the right blocker, you should investigate how good it is, right? You should select the one that's been tested. And this is where you find. And they would update this periodically. So if you see a new device that you want to purchase, right? And they're not cheap either. $500 is for a small device, right? So. And the reason why it's named Bridge is because it's connecting drive to drive, right? Okay. Then answer those questions. What are the result key? And then the tool that was used for analysis, you should see, it will tell you like what they used for the analysis. I think earlier we talked a lot about live image compared to dead, or live analysis compared to dead analysis. So if a system is running and it's on and you're doing live analysis, you can actually capture the live image of it that it's running. So when should you do that? You should do that when someone encrypted the full disk. And people can do that, right? They can encrypt the whole drive. Or malware encrypt the whole drive. Ransomware does that too. When applications are running, I put when applications, see. When malware or other software may be in using memory or have memory resident without copying the disk, and you need to collect the image while it's running. So do not turn it off. I wouldn't recommend that you shut things off when you see it first, right? Even if you're gonna capture the image. So capture the live image when it's on. And if it's, if it doesn't fall into this category later on, you can shut it off. They would have to remove power if they confiscate it or something like that. But you want to capture things that are on, especially when you see that things are running. Because you also get traffic sometimes. You also get like, whatever state for the applications and the files gonna be. So that brings us to the next area, which is gonna be the restrictions or the disadvantage of this. Okay, so the limitation for live system imaging is that it leaves remnants. It doesn't cleanly capture everything. That means that you might not have everything. Okay, because the imaging utility, when you mount it, you should use a removable drive, and that's going to be your destination drive. So you want to be able to store the live image onto it. The content of the drive or the memory may change during the imaging, right? So if I have things that are running and it consistently change every so often, by the time I capture the image, the change has already occurred or it proceeds to additional changes, right? So the state of the system change as it is running. So you can only capture things at the moment in time. 5 minutes later, it's different. So you are going to have some offset or differences from the time that you capture until the time that it's done. And this is an endless cycle that we're going to see. So you can only capture it at a moment in time. That's what it's saying. And then when you deal with malware, it's only able to detect it if the tool that you use has that capability. And a lot of the times, if you use the forensic suite, they would have that, so you can submit it for scan. Because sometimes you don't want to transfer that malware to your own system either, right? So we want to make sure that we disable it or avoid it, quarantine it, but on the image itself. And then live image do not include unallocated space, as it is a copy. Okay, and then lastly, I know that you want to proceed to the next part. Some of the tools that you can use to view your logs, we talked about this earlier, and many of you probably heard of Splunk before. They're very popular. Sawmill, Event Log Analyzer. Those are some of the common ones, but yeah. There are tons others. If you just Google it, you will find tons of them. You know, depending on what kind of license, what kind of, you know, application that you want to purchase. Now, when you purchase log viewer or log content viewer, you should try to get one that does a lot of analytics for you. Some of them actually, you know, is web oriented, where it gives you like, you know, the visual, and then it also allows now to implement an AI. So that's very helpful. Any questions? Oh, I forgot 26. I thought I stopped at 25. But 26, last question. What type of tools is used to capture memory, or what type of tools are used to capture memory of your memory resident data in your Linux system? So you would use FMEM and Lime. You're gonna see Lime today, or part of Lime today. But because some of the tool that's like volatility framework, it's built with Lime. But that stands for, you know, Linux memory, something, I forgot the name, but we'll look at it shortly. Any questions? Not too bad, huh? But the notes contain a lot more details, so if you like this, you can go through it. 12 pages. I think it was like 60 or 80 pages in note for the chapter 80.
Nearing the wall.
A lot of it is screen captured. They have a lot of images in the text. So one of the things that I didn't include in your questions are the procedures, right? Likely that when you get the certification questions, they might want you to know the overall. So we have to plan out what we're going to try to find, right? Because the data is going to really determine the techniques. Remember that for forensic. So have an idea of what you're going to do, so that way you can select your tools and your resources. Then this is going to help you. So I normally would think about like how I would map out the data, where it is located. Sometimes it's through on the network. You have to go through multiple systems. Sometimes it could be on the system and the cloud. So you have, and that is going to help you understand like what tools you want to use. And then you want to document. So as you go, everything that you do has to be documented. The procedures needs to be included into your litigation report. So for the legal aspect, we have to report that. And then obtain the evidence, perform the analysis, right? And then write the report. So the report from the application is going to be your finding. You have to interpret your finding. Like, what does this mean? Okay. And if it's volatile, right, that means that when the power is removed, we gotta make sure that we note that. Okay. So we're gonna do the lab with volatility. They default it to the browser and the browser is outdated. So let me try to see if I can log in their application again. And you don't have to use the one on your drive. You can download it and extract your Kali if you want. At home, you can use Ubuntu on this one too. The app is outdated, the browser is outdated. I am done. Yeah, all right, I'm just using my laptop. I think I have a Kali version on here. Let's see if we can start. As I test it on your system to make sure. Okay, so while we are getting things started with our lab, right, I know some of you already got started. If you don't have a virtual machine, you can download it. Let me zoom in. Some of the steps does take a little time, so I want to make sure that we, even though it's short, it seems short, but it might not be short. I know when you get to the upgrade version, it's taking forever. Oh, it's a good 10 minutes. Okay, so we load it, we log in. Let me get my, let me get this one. Okay. So once you're in it, what we're gonna do is we are gonna use volatility framework. There's version 2 and now it's version 3. The version 3 is what you want to use. Okay. Version 3 is with Python 3. My experience with this, it's great running directly with Python. But when you visit their website, you would see that, you know, their documentation. I actually have, let me pull up their GitHub. So when you go to their website, which is volatilityfoundation.org, you can find the information here. There is the source code and all the version information. Let me see if I can find their GitHub page. If you go to downloads. Earlier I was snooping around and I saw their GitHub information, but I use their GitHub. It is a better source. If you search for volatility 3, you'll find their GitHub page. So this is what you need to get started. I kind of buffer a lot of the things out and wrote down the lab for you because, just doing this might not work. Okay. So this is a cross-platform framework. That means that it works with different OSs as it is Python. So it's written in Python. So if you have a Mac OS, Linux, and server and Windows version, you're able to run it. It also support other areas like virtualizations, emulator, QEMU. I've used QEMU before in my 30B class. And then also directly with DD, and so on. Okay. So when they tested this, and I pulled this from their website, they have used it with FTK Imager, Helix, Lime, and you can click the link to go to Lime. So that way, basically, we are going to install the framework, which gives us the tool and be able to do this. So I wrote a similar lab a year ago, or not even that, when you guys took 27A. I revisited that lab and I tried to do some of the steps. Of course, it changed. So I had to rewrite some of the steps, but this is the updated version. So here we go. You are going to Git clone, this is where you're going to download so open up your terminal. And then you're going to Git clone from their repo. Okay, so we got that. The next step, so once you download, right, that's the procedure. Then you are going to update your entire Linux system. The reason why we do this is if you don't do that, when you get to this step, you will not be able to run it. So Python, like all the C-based language, needs some form of builder, right? Even though it's Python, I teach Python and I always say, oh, it uses the interpreter. But when you run it as an application, as it is written for cross-platform, you need GCC, which is your C compiler, okay? It needs to build it. It needs to build it as a program, and then you can install it because that's how they wrote the source code. So without the build essential package, you will not, Linux Debian comes with GCC, right? We want to make sure that we have it. So I wrote these steps to make sure that so Python directly, we don't run it as source code. We run it as a Python program. So this is why we need this. Okay, so we are going to do the update and upgrade. So update, that it's only going to pull the update file. Upgrades is going to upgrade the version. That's going to take the longest time. Type in the password. I think my VM is a little older compared to if you downloaded the new one. I tested on the new one earlier here. It seems fine. Okay, so while that's working, right, I talked a little bit about this. So I know that Python version is already installed. I think 3.11 is on your latest Debian. And then when you update, but I want to be sure. So in the case that, some students might get a hold of this via YouTube and start running it on Ubuntu, or some Debian version. So I want to make sure that we install. So with this, we install the Python install package along with Python. So when you issued this, right, you can also do Python -- version. You can find the version number that's installed, right? So we make sure that Python is installed. I talked about how we need to do the build essential package. This is for GCC, which is your compiler. Okay. So as you pull the Git, the repo, you would have a folder called volatility 3, right? You need to access it. Then you're going to have access to the setup.py. So you know how on Windows you run the install, the setup, they convert the code into, .msi so that way you can install on your Windows system. But ultimately, when you work with, like just source code, it is just a Python file like this. So it has function on, what's activated to do the setup. After we set up, we're gonna do the install. If you read their documentation, they have a text requirements thing that's already been downloaded. You can also run that requirement file. I didn't want to bother with that, so I just did the compiler. It's easier for me. Okay. And the main source code for the application is coming from the vol.py from the repo. So you're gonna run that. What does this do for you? It's gonna give you analysis for what's running on the system that we're gonna download, the image. And then we're gonna look at whether, malware is functioning, and so on. Okay, so we're gonna look at the vmin, the processes, the network traffic, all of that for that system. This is a live capture that someone did, right? And then I pull it from their website. So as you go through the step, even though the steps are very few, I want you to look at what's being output. Like it's gonna show you the processes, the parent and the child processes. And then you can also look at malware, network connection, the whole deal. Okay, so you have a better understanding of how live capture works for analysis and what we would use. This is valuable. I bet you a lot of people who doesn't really dabble into this, they don't know how to use this stuff. Okay. Let me see where mine is. It's not even at that upgrade section yet, right? Where it gives you the status bar on the version. So this is gonna be like 10 minutes here. Oh, I saw something online. I shared it with Nasa earlier, but I want to share it with you. This actually.
Oh, do you want to tell them about the voucher thing? Just to do this?
Oh, yeah. So she had told me that the voucher that I have for CompTIA, it makes you schedule it by June 2nd. I will talk to CompTIA rep sometime this week and early next week. I'm not sure when they're gonna be able to communicate with me about extending the expiration date. I'm gonna try for that because we have many vouchers that we haven't used.